Alright, hi guys. So in this video we're going to be going to a practice question on kinematics. So actually it doesn't come up a lot, so it's very difficult to actually find those questions, but we found a couple here. So what we're going to do is we're going to actually try and go through these right now. And then afterwards I'm going to point out something small about a kind of question that might come up, though it's not actually been put in here. So a particle is moving along a straight line, and at time t seconds, the displacement of the particle from a fixed point of the line is given by s is equal to 4t cubed minus 22t squared plus 24t plus 31. So let's look at the two questions and subparts. So since kinematics isn't that tested on, there aren't that many questions available. However, I do encourage you guys to just know generally how it works and to watch the introduction video if you haven't already. So part A, find the values of t when the particle is instantaneously at rest. So if you want, you can pause the video and go through these questions, but I'm just going to go right ahead. So instantaneously is one of the words that we were using. So instantaneously means at a given time of t. And then the other keywords are at rest. So at rest is when the velocity is 0. So what this tells us is we have to differentiate the function to get velocity as ds over dt, which is equal to velocity, is the derivative of this, which is 12t squared minus 44t plus 24. So this here is the velocity function, and at rest means that the velocity is 0 because it's not really moving at that point. It's not really moving at that point. So what we're going to do is equate this to 0, so 12t squared minus 44t plus 24 is equal to 0. So what we're going to do is we're going to solve this equation to find the roots. What we can do is divide everything by 4 because each term is divisible by 4. So we get 3t squared minus 11t plus 6, and it's going to equal to 0 because 0 over 4 is still 0. Then when you factor this, so we know that 3t is on one side, t is the other. By inspection, we can see it's minus 3 here and minus 2. Yep, they add up to 11 is equal to 0. So t is equal to 2 over 3 or 3. So over here we have the 2 over 3 root. Here we have the root 3. So the answers are at time is 2 over 3 and 3 seconds. So it's asking us to find the values, the acceleration of a particle when it is instantaneously at rest for the first time in part B. So acceleration we know is the derivative of velocity. So we're going to say A is equal to dv over dt, which is 24t minus 44. And saying it the first time is the first time that equals at rest, right? And between 2 over 3 and 3, 2 over 3 is the one that takes place first, obviously because it's smaller. So when t equals 2 over 3, a equals 24 times 2 over 3 minus 44. So if you cancel out the 3 and 24, you get 8 times 2, so it's equal to 16 minus 44, which is equal to negative 28. Don't forget the units, which is meters per second squared. So that's the acceleration, which means it's decelerating at that point. All right, let's go through one more problem before we wrap up this video. So as I said before, kinematics questions are hard to come by, but I found another one. This one actually has the most kinematics questions pulled from past papers. So what I'll do is I'll put the link to this document. Obviously, you can see from the watermark that's from Alvin Academy. So Alvin Academy has a lot of kinematics questions. So directly from AdMath's past papers, I'll put that in there. All right. So let's do part 1. So find the initial displacement of the particle from O, given that a particle moves in a straight line such that displacement x meters from a fixed point O after t seconds is given by x equals 10 ln 2t squared plus 4 minus 4t. So let's put out some of the key words. Remember the language we covered in the introduction video is very important to consider. So saying initial displacement. And we're told the displacement is represented by this function. Initial means that at time 0, as we had said, from the origin. Remember, it doesn't have to start at the origin, it can start somewhere else. So when t is equal to 0, when t equals 0, that's what initial means. So x is equal to 10 ln, then 0 squared plus 4 is just 10 ln 4 minus 4 times 0, which is equal to 10 ln 4 minus 4. And we can use a calculator to get a more specific sense of what this is. So 10 ln 4 minus 4. This is somewhere equal to 9.86 meters. So that's the initial displacement. That was a 1 marker. Tells you it's very easy. In this case, you just need to identify t as 0. So find the values of t when the particle is instantaneously at rest. So instantaneously, remember, that's depending on the value of t. But at rest, we know that's when the velocity is 0. So velocity equals 0. They've given us the displacement function, but we know that the derivative of displacement with respect to time is equal to velocity. So since v is equal to dx over dt, let's differentiate the function. So it's 10 times, and then we know how ln differentiates. So ln, basically the function inside, the derivative of that goes in the numerator, and the function in itself goes in the denominator. So t squared plus 4, if we differentiate that, becomes 2t, and the denominator becomes t squared plus 4, it just becomes the same thing. And then negative 4t becomes negative 4. So this is the derivative. We want to simplify that down. We get 20t over t squared plus 4. Let me just scroll down. T squared plus 4 minus 4. So it's saying at rest, which means you have to set this to 0. So let's do that right now. So 20t, then we solve now for t. T squared plus 4. Remember, they're values, and since we have a quadratic value in here, we're likely getting 2 values. So let me just drag this up here. So 20t is equal to 4t squared plus 16. If you make it all into one side and get the quadratic, 4t squared minus 20t plus 16 is equal to 0. Now we can see that 4 can be divided by each term. They're all divisible by 4. We want to make it as simple as possible. So t squared minus 5t plus 4 is equal to 0 over 4, which is 0. So if we factor this, we get t minus 4 and t minus 1 equals 0 from inspection. So therefore, t is equal to 4 and 1. It's a weird way of writing it. Let me write 1 and 4. So these are the times 1 second, 4 second. And these are the times when the particle is instantaneously at rest. So that's a 4 marker. It shows you do need to do a little bit of work to get there. And the final part of this question is find the values of t when the acceleration of the particle is 0. All right, so the acceleration, we know that this is equal to the derivative of v, velocity with respect to time. So let's differentiate this velocity function. So our velocity function is the derivative of, our velocity function is 20t over t squared plus 4 minus 4. So let's differentiate that. So the first thing we need to do is take note of this function over here. This function will require us to actually use the quotient rule. So quotient rule. Since we have a numerator and denominator. So let's say u is equal to 20t. du over dt is equal to 20. Then our v will be the denominator, which is t squared plus 4. Then dv over dt is equal to 2t. Now we just substitute your values into the quotient rule, which is the derivative of u with respect to t, which is 20, times v, which is t squared plus 4, minus the derivative of v, which is 2t, times u, which is 20t, over v squared, which is t squared plus 4 squared. And then this is subtracted from 4, but remember that the 4 is a constant, so it gets removed. So if we simplify this down, we get 20t squared plus 80 minus 40t squared over t squared plus 4 all squared as the acceleration function. Remember, we're going to set this to equal to 0 because it's saying when the acceleration is 0. So now we have to find the value of t which suits this. So we multiply both sides by t squared plus 4 all squared, and we get 20t squared. Oh, remember that 20t squared, we'll do that next. Plus 80 minus 40t squared is equal to 0. Now we can combine these terms because they're both they're attached to the same power of t. So that gives us 80 minus 20t squared is equal to 0. So 20t squared is equal to 80. T squared equals 4. So t is equal to plus minus 2. But But remember that they're asking for the value. That's a good indicator that there's only one appropriate value. And the way we can actually determine this is the fact that time can only be positive. So therefore, it's not like displacement or velocity or acceleration, which can be negative. Time is only positive. So therefore, answer, let's write this, t equals 2 seconds. So there you have it. We've gone through all these questions quite methodically. And this way I've been able to show how differentiation is very useful in kinematics. In another video, I will make a video on how integration links to kinematics, because I do feel that's really important to learn, and it just might, cover some more gaps, such as find the total distance a particle has traveled rather than just a displacement, and gives more opportunity for exploration. But thank you so much for watching this video, and bye for now.